Good morning. We are in the topic 9 of the course Introduction to Probability Theory and Statistics, and the topic 9 is Descriptive Statistics and Statistical Distributions. In the first lecture we have already covered descriptive statistics. In the second lecture we have discussed about the statistical distribution introduction and the statistics. And in the third lecture we are going to discuss about the three important distributions, that is a chi-square, students t distribution and f distribution, followed by some important results on sampling distributions. With this the topic 9 will be completed. Now let me go to the first standard distribution, which is very important to the sampling distribution, that is chi-square distribution. This is a continuous type distribution which has the probability density function. If you see this probability density function, you can be able to relate one standard distributions of continuous type. You can be able to relate by seeing the gamma function in the denominator and so on. So, this distribution is called a chi-square distribution with the one parameter. It is a one parameter continuous type standard distribution and whose probability density function given as follows. The notation is a chi superscript square, and whatever the parameter value you can write it in the bracket. So, if you change the parameter values, you can see the different probability density function. For illustration, we have made it for the parameter values 2, 4 and 7, like that you can see the colors. By assigning some values to this parameter, you can be able to get exponential distribution. That is the one observation from here. And another observation is by seeing the probability density function itself, you can feel it for a larger value of parameter, the probability density function will be approximately a probability density function of normal distribution. That also you can feel it from the probability density function graph. So, these are all the simple observation from the probability density function as well as the graph which I have given. It is easy to compute mean and variance for the chi-square distribution, and the mean of this chi-square distribution is same as the parameter nu, and after you compute the second order moment, you can able to get the variance also. So, variance is 2 times nu. Not only that, you can find the further moments also. So, I have just listed few other moments also one can easily compute. The way you can compute the higher order moments that we have given in the probability theory course, probability theory part. From there you can use the same logic to find the higher order moments also. The another observation is if you take a parameter value is greater than 30, then it is possible to approximate by subtracting the mean. X minus nu divided by square root of 2 nu follows a standard normal distribution. So, that will be approximately a standard normal distribution. That means for a larger value of the parameter nu, by subtracting the nu divided by the square root of 2 mu, you will be approximating with the normal distribution, that is a standard normal distribution. And another observation is it is possible to get the tail probability. For a given tail probability, what is the parameter you can able to get it. Not only just a tail probability, it is a right tail probability. That means for a given alpha, for a given right tail probability, what is the point in which the probability of a chi-square distributed random variable from that point to infinity becomes alpha. So, if you see the table carefully, you can able to see for different value of alpha, for different value of parameter, what is the right tail probability you can make out. So, it is possible to, so basically it gives the point, it gives the point in which the right tail probability is going to be alpha. For a given alpha, for a given parameter, what is the point in which you will get the right tail probability is alpha. Why the right tail probability is important, that we are going to discuss in the estimation and hypothesis testing. At present you will understand what is the point in which you will get the right tail probability is alpha for a given the parameter nu. So, that is what we specified in this table. Similarly, we are moving into the next important standard distribution, that is called the student's t distribution. This is also a continuous type, therefore, we supply the probability density function of it. Both numerator and denominator has a gamma function. It is possible to relate the standard normal distribution with the chi-square distribution. One can able to create the t distribution using a function of random variables. So, that also we have explained. Suppose you have a standard normal distribution z, we usually use the notation z for standard normal distribution. Then we have a chi-square distribution which is independent of z. Then you can make a function of random variables by z divided by square root of x divided by nu, where nu is the degrees of freedom for the chi-square distribution. The same freedom is called the degrees of freedom. So, if you make this way ratio, you will get the t distribution. That means, if you find the probability density function of y, that boils down to the probability density function of a t distribution with the nu as the parameter. That is going to be called it as a degrees of freedom. For different values of nu, you can draw the probability density function. By just seeing the probability density function, you can able to conclude this is sort of a normal distribution. The only difference is it is not asymptotically 0 in both left and right limits. But if you increase the value of parameter, then this will converge, or this will be approximately a normal distribution, standard normal distribution. It is going to be a standard normal distribution for larger value of nu. You can able to get the mean is going to be 0, and variance exists provided the nu is going to be greater than 2, and for a larger value of nu, you can able to approximate it with the standard normal distribution. Whereas, if you see the chi-square distribution, for larger value of that parameter, it becomes a normal distributed by subtracting the mean divided by the standard deviation, it becomes a standard normal distribution. So, there is a difference between chi-square distribution with the t distribution. That is one observation. Here also we can able to get the point in which the right tail probability is going to be alpha for a given parameter nu. For different value of alpha, for different value of nu, what is the point in which the right tail probability is going to be alpha. Since it is symmetric, you can make a probability of absolute of t greater than the point, that is denoted by small t nu comma alpha by 2, that probability is going to be alpha. Because you made it a absolute of t, therefore, you will have a right tail is going to be alpha by 2, left tail is going to be alpha by 2, therefore, you write a probability of absolute of t greater than this point, that is going to be alpha. The probability of t greater than t 5 comma 0.05 is 0.05. Now we are moving into third distribution, that is F distribution. This is also of a continuous type random variable, therefore, the probability density function of the random variable x is given. But this has the two parameters nu 1, nu 2. Therefore, for different values of the parameters you can draw the probability density function and you can have a look how it looks like. And here also you will get the conclusion for a larger value of nu 1 and nu 2, you can approximate the F distribution also into the normal distribution, not the standard normal. It is going to be a normal distribution. Only in the t distribution you can get the standard normal for a larger the parameter values, whereas the chi-square distribution and F distribution whose means are different. It is possible to create the F distribution with the help of chi-square distribution. If you have a two independent chi-square distribution with the corresponding degrees of freedom, if you divide and then make a ratio, that becomes the F distribution. It is possible to find the higher order moments also, that I have listed out. I do not need to read the things. By simple calculation you can able to get the first order moment, second order moment and all the higher order moments. This way you do it for the any random variable whose distribution is known. Here also we can go for the table value. Oh, before that I did not tell you why we make a table value. That part I missed it. I would have been explained in the chi-square distribution itself. It is not possible to get the probability of some interval in a closed form. All three distributions starting from chi-square, t and f distribution, there is no way you will get the closed form expression for probability of some interval of that random variable. Obviously, you know from minus infinity to infinity that is going to be 1, but for any other interval it is not possible to get the closed form expression. Therefore, numerically one can able to get the probability of we are interested in that right tail probability, that means the probability of that random variable greater than that point to infinity, that we are numerically computing. It is a numerical integration and the tables are made. So, all the three distributions chi-square and t distribution and f distribution, it is not possible to get the closed form expression for the probability of some interval. Therefore, we land up the table. There is a difference between the table of this with the earlier two tables. The earlier two distributions involves only one parameter. Therefore, you fix the parameter, you fix the right tail probability, you can able to get the point in which the right tail probability is going to be alpha. But for F distribution it involves two parameters. Therefore, it is not easy to show in a table form for both possible values of two parameters as well as alpha as well as the point. So, what we do is we fix the value of alpha. Alpha is the right tail probability, it can lies between 0 to 1, but in general in the statistical analysis we need the statistical analysis with 99% confidence or 95% confidence or 90% confidence and so on. Therefore, the negation of that percentage in a probability way, it is going to be the alpha value. There is a connection between alpha from the confidence in which you are want to conclude any observation. So, if it is a 99%, the right tail probability or both right and left tail probability has to be 0.01. If it is 95% confidence you are looking for it, then we always make a alpha is going to be 0.05. If it is a 90% confidence, then the alpha is going to be 0.1. These are all the typical scenario for any statistical analysis. We need alpha of these three, not only these three, we can go for 85%, 80%, 75 or any number, but the important observation is most of the time it goes to 99% or 95 or 90%. Therefore, the alpha is going to be fixed either 0.01 or 0.05 or 0.1 and something more. So, these tables are made for different alpha values. For example, here we have given alpha is equal to 0.05. So, the table is fixed for fixed alpha and we vary the two parameters in x axis as well as our row and column. So, the row wise we keep one parameter, column wise we keep the another parameter, and inside we give the point in which the right tail probability is going to be alpha for a given first parameter and the second parameter, and the whole table is for a given alpha or fixed alpha. Like that we will have many tables for f distribution, we will have many tables and each table is corresponding to fixed value of alpha. Fine. When you write the notation, you should write the first parameter comma second parameter then the alpha. If you start using that type of notation, then you will find if you it is not symmetric with respect to parameters. So, if you change the parameter, then you can get this relation what I have written in 4.13. It is possible to get the relationship between f of first two parameters nu 1 nu 2 with alpha and nu 2 comma nu 1 with 1 minus alpha. This relation, reciprocal relation, one can conclude. So, with this information I am giving a very introductory information about these three distributions, telling about what is a probability density function, what is the higher order moments and how the probability density function look like and why do you need a table and what is the table value for a given alpha. That is all we discuss. There are many more we can discuss about these three distributions that we will be seeing over the period of time when we come across the different concepts. Now, I am coming back to some important results on statistics. We have already discussed what is a random sample, what is the population, what is the distribution of the population and so on. Suppose you do not want to fix the distribution for the population, still you know the population mean is mu and the variance is sigma square. Since the samples are random, you can easily able to get the mean for the sample mean. That means you know the mean for each exercise, that is going to be mu, and the sample mean is just a summation of exercise divided by n. Therefore, n mu times divided by n, therefore, the mean of sample mean, that is going to be mu. Similarly, you can find the variance, but computing variance is little tedious job than the mean, because here you have to use the assumption of they are all random samples, they are all independent, therefore, each exercise are independent. Therefore, when you compute the variance of x bar, that is variance of a summation of exercise divided by n. So, you know how to compute the variance. It involves the covariance between any two random variables also, but since they are all random samples, they are all mutually independent, therefore, the covariance quantities are zeros for any two random variables. Therefore, it is going to be a sum of all the individual random variables, and already you have 1 by n outside, therefore, it becomes 1 by n square. So, 1 by n square times n sigma square. So, if you simplify, you will get sigma square by n. So, that is the way you will get the variance of x bar, that is sigma square by n, immaterial of whatever be the distribution of the population, as long as you assume the population has the mean mu and the variance sigma square, always the sample mean, the mean of sample mean is going to be same as the population mean, that is observation, and the variance of the sample mean, that is always population variance divided by n. From this two quantity, you can able to conclude something more by seeing a variance of x bar is sigma square by n. N is the sample size. Obviously, if you increase the sample size, what will be the nature of variance of x bar? That becomes yes. So, the variance of x bar will tends to 0 for as n tends to infinity. Okay, by default we assume that the population is infinite size. By default you assume that the population is infinite, and you have taken n samples from the population, and we got the sample mean, and the sample mean variance is always sigma square by n. Now, the observation is for a larger n or as n tends to infinity, the variance of x bar will tends to 0. So, what is the conclusion? Variance of x bar is tends to 0 and the mean of sample mean is mu. What is the conclusion?
X bar is almost everywhere equals to mu.
Yes, for a larger n, the sample mean approaches population mean, that is mu. For a larger n, means that sample size n, the sample mean approaches to the population mean, that is the observation from the first result. All those things we are discussing associating the random sample of size n with the random variable. There your probability theory knowledge is used to study the statistics. The x bar is a statistics. Whenever you take a n samples, you will get the different values. Therefore, we are we are associating one random variable. Therefore, x bar is also now random variable actually. So, we are finding the mean for that random variable, variance for that random variable, and we are observing many things. Even by mistake, we should not use the word average, because it is a random variable. The mean is different from average. Then your question will be, when we can say mean and variance can be interchanged? When the underlying distribution is uniform, whether it is a discrete type or continuous type, then you can interchange the word mean and average. if you did not specify any distribution for that random variable, then you cannot interchange the word mean and average. So, here we are not fixing any distribution for the population, we have fixed only mean and variance exist. That means you cannot discuss the statistical statistics of some population does not have even a first order moment or second order moment. There is a theory, once the nth moment exists, the previous moments obviously exist. At the same time, it does not guarantee the n plus 1th moment exists. So, here we always discuss about the population in which at least second order moment exists, then only you can talk about a population is mu and the variance is sigma square and you do this and all the observation, fine. Now, we are coming into population with the finite size. If the population is of the finite size and you have taken without replacement and keeping the assumption mean is mu and the variance is sigma square for the population, then also one can find the mean for the sample mean as well as variance for the sample mean. Here also we are not fixing the distribution of the population. Now, we are restricting the population size is finite. In that case, the mean does not change. You see the mean expression, mean for the sample mean is same, but the variance as a function of the population size also. There also you can feel it as n tends to infinity, what will happen? Suppose the population size is infinite, you will get the previous result, that is sigma square by n. And not only that, if you find the mean of sample variance, we can go for finding the mean for sample variance, that is S square, additional next statistics we are finding the mean, that you can as a function of a population size. And there also you can easily conclude as n tends to infinity, that means the population size is infinity, then the mean of sample variance converges to the population variance. The earlier observation, when the sample size is increased, we said the sample size is increased, we said the sample mean approaches to the population mean. But here the observation is when the population size is infinite, then it is easy to conclude the mean of sample variance will tends to the population variance. Whenever we use the word with keeping random variable in the picture, you should remember in what mode of convergence this takes place. This is with respect to random variable, I am saying x bar sample mean converges to the population mean. Now, I am saying the mean of sample variance converges to the population variance. That means what you say about S square in terms of sigma square. Then we should go back to the limiting distributions or a different mode of convergence, whether whatever the word which we are using convergence, whether it is a convergence in probability or convergence in distribution or convergence almost surely or convergence in rth order moments. So, the first conclusion which made x bar converges to mu, that is in probability, whereas since we got expectation of S square tends to the population variance sigma square, this is S square converges to sigma square in second order moments. And further information, there is a relationship between this mode of convergence also, one implies other implies the other one, and the converse is not true. Like that there are many more relationship. So, if you understand that relationship, you can conclude many more things with respect to the statistics and the parameter of the populations. because here the population parameters are mu and sigma square, that is population mean is mu and the variance is sigma square, and we are discussing about two statistics, one is x bar and other one is sample variance. So, the observation is how the statistics converges to some function of parameters or just a parameter itself for the population, in which mode of convergence also can be discussed. Now, we are coming into another result, that is what could be the distribution of sample variance. The way we discussed the distribution of sample mean once you know the population distribution. The same way, suppose you assume that population follows a normal distribution with the mean mu and the variance sigma square, then you go for taking n random samples and associated random variables are x1, x2, xn. Obviously, they are IID random variables. Each one follows normal distribution with the parameters mu and sigma square. Using that you can able to conclude the sample mean, that is going to be a normal distributed with the mean mu and the variance sigma square by n. And you have created the sample variance, that is a function of n random variables as well as the sample mean. So, each x size follows a normal distribution with the mean mu and the variance sigma square, and x for x bar follows normal distribution with the mean mu and the variance sigma square by n. You can do all concept what we discussed earlier in the probability part. You can able to find the distribution, not just s square, n minus 1 times s square divided by sigma square, you can able to get it as a chi-square distribution with the n minus 1 degrees of freedom. Even though I said we are going to find the distribution of s square, we are finding the distribution of n minus 1 times s square by sigma square, that is going to be a chi-square distribution. That is what we discussed chi-square distribution before this part. It is a simple exercise, you can able to do that. The way it is in the right side, some summation expression, you can take n minus 1 in the left side, therefore, you will have n minus 1 n square. So, you have a summation in the right side, and you can divide a sigma square in both side. Therefore, left hand side you got now n minus 1 times s square by sigma square, and the right hand side you will have 1 divided by sigma square, that summation. Now, to conclude that is chi-square with n minus 1 degrees of freedom, you have to do little algebra. That means that summation I is equal to 1 to n of xi minus x bar whole square, inside the bracket you have to add and subtract and make it 2 terms in it. Once you make a 2 terms nicely with the mu, now I remember xi minus mu plus mu minus x bar. So, you keep xi minus mu as a one term, x bar minus mu as another term. So, you will land up suppose you treat this as a and the next one is b. So, you have a minus b whole square, where a is xi minus mu and b is x bar minus mu, and this inside summation becomes a minus b whole square. You know how to expand a minus b whole square. You will have 3 terms, a square minus 2ab plus b square. You simplify, then you use some properties of chi-square distribution. After all the simplification, you will get it is same as it is going to be a chi-square distribution with n minus 1 degrees of freedom. It is a simple exercise, you can do that. Now, we are coming into the next result. Here also I am not going for complete derivation, it is there. The very important information is whenever the population follows a normal distribution with the mean mu and the variance sigma square, always you can able to conclude or you can prove sample mean and the sample variance are independent. And the proof is available in many books and you can derive, we have also derived. So, it is able to find out or conclude both the random variables are independent. There are many ways to conclude two random variables are independent. So, you can use any one of the approaches and you can conclude. Even though you are intuitively will say how come sample variance is independent with the sample mean, because the sample variance has the term sample mean inside. It is a function of sample mean. How I can say that sample variance is independent of sample mean? That is what we have given the proof, or that is what it is proved. Whenever the populations is a normal distribution with the mean and the variance given, you can able to conclude both are independent random variables. We are talking about the random variable x bar and s square. Two more results, that is suppose you have a population variance which is sigma square is unknown. Till now we are saying whenever we say the population has the normal distribution with the mean mu and the variance sigma square, by default both are known. But suppose we make the assumption you know the mean, but you do not know the value of variance, population variance, which is unknown. Then it is possible to create the random variable, or you can able to replace the population variance by the sample variance. In the same way, the population standard deviation can be replaced by the sample standard deviation. Therefore, you can create the new random variable called x bar minus mu divided by s divided by root n. N is the sample size. Then it is possible to prove that is going to be t distribution. Fine. That also it is a simple exercise how to find the distribution of a function of random variables, because in the right hand side x bar is a random variable and s is also a random variable. For that you have to use the theory population follows normal distribution. Therefore, your sample mean follows the normal distribution with the mean mu and the variance sigma square by n, and in the denominator you have small s. That means whenever you have a sample size n, n minus 1 times s square divided by sigma square, that follows a chi-square distribution with n minus 1 degrees of freedom. Then the theory I told you earlier, when you have a one standard normal distribution and the denominator chi-square distribution divided by the degrees of freedom, that ratio becomes a t distribution with the same degrees of freedom of the denominator. That is what we can able to conclude, that is going to be t distribution with the n minus 1 degrees of freedom, provided the population variance is unknown. Therefore, you replace it population variance by the sample variance. Same way, it is possible to create a f distribution with the sample size of n1, similarly sample size of n2, two independent normal distributed populations. Say you take two different samples of nu1 and nu2 or the sample size, then if you make this type of ratio, you will get the f distribution. So, earlier I discussed only those three distribution in a raw way. Now, I am connecting with the population, samples, sample size and statistics. Therefore, this is going to be a statistics with the what is the distribution of this statistics, that also we are discussing, provided the population follows a normal distribution. And in this case we have two independent normal distributed populations, and we have taken new 1 samples from the first population, new 2 samples from the second population, then we make a ratio. Why do you make this type of particular ratio, that we are going to discuss later part. So, this is going to be of a very special type of this type of ratio going to play an important role for the topic number 10 and the topic number 11, that is estimation and the hypothesis testing. Therefore, you cannot do any other ratio, you have to make this type of ratio. Finally, you will end up sample variance of the first samples divided by population variance divided by sample variance of the second random samples divided by population variance of the second population. In that ratio will form a F distribution with the 2 degrees of freedom, that is nu 1 minus 1, nu 2 minus 2. That means that these are all the parameters of the F distribution. Fine. With this, I have completed what is the meaning of statistics, what are all the 2 important statistics, that is sample mean and the sample variance, and 3 important standard distributions related to the any statistical inference, chi-square student t distribution and F distribution, and then we have given some important results which we have discussed. Now, I thought of giving one problem, how one can solve simple problems in the real world problems using the statistics concepts whatever we have studied till now. So, you go through this example, I am not going to read out, you can put a pause and you can go through this example carefully, and you can get what are all the information you can get it from this example. By go through this again and again, you can able to feel the question is what is the probability that the average price of a sampled stock will be less than some rupees, 497 rupees. That means, we should think of abstracting this into the correct way based on the previous information. Then we should be able to relate whatever we have studied till now. Actually, I have not given any extra information to apply the earlier concepts which we have discussed, and also I have not given less information also. Every informations are very important to move further. You can try yourself. You can put the pause and you try yourself and you see whether the results which I am going to write down and the results which you got it, whether both are one and the same. Fine. So, when you go through the question, you would have understand you can create a random variable called x bar, that is nothing but the average price of a sampled stock which is represented by x bar. And you can able to conclude the mean of x bar is mu and the variance of x bar is sigma square by n. From this problem you can able to get another information, that is mu is going to be, mu is 500, and the next information, the sigma, that you can able to get 100, and then you can able to get what is the size of the sample, that is n, that is going to be 50. This many information you can get it from the problem which I have explained. Now, the question is, what is the probability that x bar is going to be less than or equal to 497. You can subtract the mean divided by the standard deviation in both sides divided by the standard deviation of x bar. Therefore, your next step is going to be x bar minus mu divided by sigma by root n less than or equal to 497 minus mu divided by sigma by root n. This can be by treating n is large approximately a standard normal distribution, which is since it is less than or equal to, I can use the notation psi of 497 minus mu divided by sigma by root n, where psi is nothing but the probability between minus infinity to this point for a standard normal distributed random variable. So, that we have well defined in the earlier also. So, psi is nothing but probability of z is less than or equal to this point. So, this you can able to get it using a table, and that is same as if you do the little simplification, you can able to get yes. So, it is possible to use the table by substituting the value of mu and sigma and n and simplify, and you can able to get the exact probability value for this psi. So, that is the answer for the questions which we have asked in this problem. Consider this example, go through the example, what are all the informations are given you can make out, and the question is what is the probability that the average price of a sampled stock will be less than 497 rupees. Let me show how to solve this problem. Let average price of a sampled stock be represented by x bar, and we know that the expectation of x bar is the population mean, variance of x bar is a population variance divided by sample size, and the information provided from the problem, you go through the problem carefully, you can get the values of mu is equal to 500, sigma is equal to 100 and n is equal to 50. The question is what is the probability that the average price of a sampled stock will be less than 497 rupees. Therefore, the required problem is, or required probability is probability of x bar less than or equal to 497. By subtracting their mean divided by the standard deviation, you will get the standard normal distribution. Therefore, you will get the psi of 497 minus mu divided by sigma by root n. Now, you substitute all the values. Then you will get the final answer is going to be 0.8. Therefore, the answer to this question is 0.8. Now, let us discuss some review problems based on the topics which we have covered till now, that is the review of topic number 9. The question is rating of a movie in satisfaction level is, there are two options, nominal data type and ordinal data type. You can able to go through the class notes and then you can come to the conclusion what will be the answer for this question. So, the answer is ordinal data. Rating of a movie in satisfaction level is a ordinal data, ordinal data type. Second question, mean, median, mode are the measures of dash of the sample. You can have many more options in your mind. You will find the answer. That is, are the measures of a central tendency of the sample. Now we will move into the third question. Skewness is the measure of, there are 4 options: central tendency, asymmetry, then peakness, volatility. Each one has a different meaning. So now we have to find out which is the correct answer. Skewness is the measure of one of the 4 options is the correct answer. That is basically asymmetry. So go through the class notes and the video lectures, then you can able to come to the correct answer. Fourth question. If xi follows a standard normal distribution and all the n random variables are IID, then the question is, what is the distribution of summation of I is equal to 1 to n xi square. Each xi's are standard normal distributions as well as they are IID random variables. So the question is, what is the distribution of summation of xi square which follows? What is the distribution with what degree of freedom? So the answer is chi-square distribution with the n degrees of freedom. The fifth question, which of the following statements are true or correct? That means there are 3 options. More than one options may be correct. The first statement is a central tendency measure gives us an idea of how a data sample has been grouped around a value. Second statement is frequency table is a display format used to analyze and record the relationship between two or more categorical variables. And the third statement is if the sample size n is odd, then the value in the middle of the ordered sample is its median. So, go through all the three statements, then you come to the conclusion which are all the statements are the correct one. Basically, the statement 1 and 3 are the correct statements. So, with this we are completing the topic number 9, that is a descriptive statistics and sampling distributions, with 3 lectures. One lecture we covered the descriptive statistics, and 2 lectures we have discussed the sampling distribution in a very brief way. As I said, you can have a separate course on sampling distributions itself. So, we are covering in a very introductory nature with a very simple example. In the next topic, we will discuss about the estimations, then later hypothesis testing, and finally analysis of correlation and regression in 3 topics. With this, let me stop this topic number 9. Thank you.